Okay, here the recording in progress. And share the screen. Okay, I think we're good. Okay, first thing I'll mention is, so lately I've been getting a 40-minute limit on the Zoom, and the time starts as soon as I log into Zoom, not when I press record. So that first minute I lost already. So that being the case, I don't think I'll join the Zoom early. I've been trying to join a little bit early in case anybody has questions early, but I think to maximize my time on the Zoom, I will try to log on right at 9:10 or maybe slightly after 9:10. So you won't see me until just about I'm ready to start. Okay, I'm going to see if I can work on that. But in the meantime, we're stuck having meetings that are under 40 minutes. I'm guessing a lot of you don't mind that anyway. A lot of our meetings don't take 40 minutes either, but now it seems like we're forced into that. But we'll see how that goes. Right, so I won't be logging in early. I'll try to log in right at 9:10 to preserve the 40 minutes. If it is true that I'm stuck on only 40 minutes, I'm going to see if I can fix it to the way it was before, but I'm not sure. Okay, next thing to notice is we're here. So you should have gotten a reply back from me on the quiz. And I also sent to you on Canvas announcements the solutions to the quiz. So hopefully it was straightforward. If you did not get your quiz back, then let me know right away. Quizzes are always out of 5. So you got a 5, 4, 3, 2, 1, or 0. And every time we have 4 quizzes, you get to drop 1. 1 out of every 4 quizzes gets to be dropped. All right, so we're moving on here. So another quiz next Friday, or this Friday, quiz on Friday the 29th, and the next exam is on November the 5th. Next slide. Okay, so let's continue where we were. Finish up 4.3, maybe go on to 4.4. Okay, so some word problems at the end of 4.3. Let's see, number 19 on page 207. Estimate the distance around the Earth at a 45-degree latitude north. Okay. That would be like around Portland, Oregon, I believe it's in 45 degree. Now the San Francisco Bay Area is about 37 degrees north latitude. It's 37, 38, I believe, last I recall. But anyway, 45 degrees, halfway up the North Pole, as it were. So here's the picture. Okay, so this is 45 degrees, which means this angle here is also 45 degrees. And here's my new radius. Okay, so the radius of the Earth is 3960 miles. Okay, so here's the picture that I have. I call this X, and this distance here is X. So cosine of 45 degrees is X over 3960. X is 3960 cosine of 45 degrees, which is approximately 2800 miles. Okay, so the circumference, if I'm up here at 45 degrees, is 2 pi r, 2 times pi times 2800, comes out to be roughly 17,594 miles. Okay, so that's going all the way around if you're at a 45-degree latitude, which is a lot shorter than if you're at the equator. Okay, I guess the main thing to say there is, you know, if someone says they went around the world or they flew around the world, it's a lot different going around the world at the equator as if you're way up here. But I guess in the most extreme case, if you're up around the North Pole, right? You're right up at the North Pole. I guess you could say you're going around the you're going around the world, but you know, you're going very little up here, obviously. And if you're down at the equator, that's where you have the biggest circumference. That's the quote unquote most impressive going so-called around the world. Okay, so if you're up in latitude of, I think the Bay Area is, San Francisco Bay Area is like 37 or 38 degrees. It's much less. So I guess you could still say I'm going around the world, but around the world is much smaller, you know, the further up you get, as opposed to going around the world at the equator. It's the largest that's possible. Okay, so anyway, that's that. Okay, 21. The angle of elevation to the top of a building is 30 degrees from the ground when viewed 1 mile from the building. Estimate the height of the building in feet. Okay, so 21, the picture is like this. Okay, you're 1 mile here. 1 mile is 5,280 feet. Okay. And you're way out here. So the angle of elevation, so that's the angle that you look up, right? So if I'm looking right at the horizon at 0, and I'm going straight up, that's 90 degrees, okay? And then anywhere in between, right? So this is 0, this is looking straight up, 90 degrees, and anything in between. So in this particular case, you're looking up at around 30 degrees. So your eyes kind of like that. And here's X. All right, so this is 5280. This is the opposite side. This is the adjacent side. So that tells me to use tangent. Tangent of 30 degrees is opposite over adjacent. X over 5280. Multiply both sides by 5280. So X is 5280, tangent of 30 degrees. Punch it in the machine, 3,048 feet. Okay. You do have to be careful in this chapter on whether you're doing degrees or radians. So you always have to check the mode. Okay, so my calculator, here there's an option for degrees or radians, so you have to make sure that you're picking the right one. This one I want degrees. And what do I want? 5280 tangent 30, 5280. I don't see anything. Oh, my machine turned off. 280 tangent 30. Sure if you can see that. There we go. 5280 tangent 30. 3,048. 3,048 feet. Okay. That's all. Pretty simple trig formula, but hope you realize this as a side note. One of the usefulnesses of trig is you can measure stuff indirectly rather than directly. For instance, you say, what's the height of this building? Well, maybe we don't feel like, climbing up here, or we're scared of heights and it's too difficult to measure like that. But it's okay to measure on the ground. I'm not scared of heights when I'm on the ground. So I can walk this way, even a mile, 5280 feet, and measuring an angle going up, that's not so hard, right? To measure an angle. So one of the usefulnesses of trig is you can do measurements without literally measuring because it's too difficult or impossible. It's safer to just walk on the ground and then just measure an angle up, and then by using trig, you can figure out heights of buildings if you don't feel like climbing up to literally measure the height here. Okay. All right, and 25, and I think that's the last one. Okay, 25, from the top of an observation tower, a forest ranger spots an illegal campfire. The angle of depression made by the ranger's line in sight is 10.5 degrees. The tower is 80 feet high. How far is the campfire from the base of the tower? And note sine of 10.5 degrees is about 0.185. You could use the calculator for that. Okay, so angle of depression is looking down. Okay, so if you're looking up, okay, angle of elevation, but you could be at the very top, right? You could be at the top of a ridge or looking down, like you'd be looking down the Grand Canyon or something. So you could be looking down. That's called angle of depression, looking down. Okay, so there's a forest ranger up here, and the measurement of the angle of depression, how much are you looking down, is 10.5 degrees, and it's known that the tower is 80 feet height. And how far is the campfire from the base of the tower? So what is this distance over here? Okay. So again, maybe we don't feel like getting out and walking this distance, or, I don't want to get too close to the fire and burn myself up. So can I figure this distance out using trig? All right, so I have this picture here, X, which is the same as the X over here. Maybe I should have drawn this. This is also X. Okay, 10.5 degrees. Here's X. Here's 80. Okay, so again, this is opposite, adjacent. So tangent of 10.5 degrees is 80 over X. Multiply both sides by X. X 10.5 is 80. Divide by 10.5. So X is 80 divided by tangent of 10.5, roughly 432 feet. And let me verify that on the calculator. 80 divided by tangent 10.5. 431.6 rounds off to 432. Okay. All right, so I'm officially done with 4.3 now, and I'm ready to start Sum of 4.4, which originally I wasn't going to start until tomorrow. So again, we're slightly ahead of what is the schedule. All right, so 4.4 now, please. We're on the sine and cosine functions. All right, so on page 208, there's a unit circle. Unit circle, center of the origin. Radius is 1. Okay, so we mentioned one way you can think of the sine and cosine is just the y and the x coordinates. So if I go along the unit circle, you give me an angle on unit circle. The x coordinate is the cosine. The y coordinate is the sine. Okay. So x comma y is cosine theta sine theta. Or you could use the letter t also. Same thing. Okay, an identity that you probably heard from trig, sine squared t plus cosine squared t is always equal to 1. Put that on your formula sheet if you need it. Okay, the author writes it like that, but the more common way to write it is like this: sine squared t plus cosine squared t equals 1. They put t, but you can use x, you can use theta. It doesn't matter what letter you use, of course. Okay, sine squared t plus cosine squared t equals 1. That's just based on the unit circle. Okay, that's the same thing as saying x squared plus y squared equals 1. Okay, this picture, you can put that in your cheat sheet. Some of you may have heard something like all students take calculus, which is the equivalent of this, meaning for the 3 functions, sine, cosine, and tangent, sine, cosine, tangent, all 3 of them are positive in the first quadrant. Second quadrant, sine is positive, which means cosine and tangent are negative. Third quadrant, tangent is positive, which means sine and cosine are negative. Fourth quadrant, cosine is positive, which means sine and tangent are negative. Right? So some of you may have heard all students take calculus. You can put this on your cheat sheet if you wish, but I don't think you need it. Okay, since we're on a unit circle, okay, the unit circle bounds are from -1 to 1 for x, and also -1 to 1 for y. Therefore, the sine and cosine of any angle has to be between -1 and 1, no exceptions. So the sine of an angle t can never be 2. It can never be -3. It's always stuck between -1 and 1. You can tell from the unit circle. It's a point on a unit circle. Well, the unit circle only goes between -1 and 1 for both x and y. So both sine and cosine can only come back with something between -1 and 1. That's not true for the tangent. The tangent can be any real number. Okay. But sine and cosine come back with only stuff between -1 and 1. Okay. Again, page 210. Property you may want to use. Cosine function is even. Sine function is odd. Okay. Cosine of negative an angle is the same as the cosine of the angle itself. Sine of negative an angle is the opposite of the sine of the angle. Okay. That can be very easily verified by punching in something on a calculator. Okay. So I'll just make up an angle. Oh, what angle do I feel like plugging in? How about I type in something like, I don't know, 17. So cosine of 17 and cosine of -17. Take a look. They come out to be exactly the same. If I can get this into focus. I hope you can read that. Get back in focus. Okay, cosine of 17, cosine of -17, exactly the same. But if I tried the same thing with the sine of 17 and the sine of -17, you see that they're opposites. Okay, so sine 17, sine parentheses -17. Okay, see sine of 17.29, sine of -17, -0.29. So the opposites. Okay, so notice for cosine of an angle and cosine of negative an angle, they're exactly the same. But for sine, looks like they're opposites of each other. Cosine of negative t is the same as cosine t. Sine of negative t, negative sine t. Okay, we've talked about this before. You can put this on your cheat sheet, although you can get it just from the unit circle. Remember, cosine and sine are just x and y coordinates. Okay. So 0, pi over 2, pi, 3 pi over 2, 2 pi. If I go around the circle once, right? Okay, cosine x coordinate. So look at the x coordinates. X coordinate 0. Oh, sorry, 1. 90 degrees or pi over 2, 0. Negative 1, 0, 1. Sine of t, y coordinate 0. Pi over 2, 90 degrees. Y coordinate is 1. Pi radians, 0. 3 pi over 2, y coordinate is negative 1. And back to 2 pi, I've gone around the circle once. Y coordinate is again 0. Okay. So both sine and cosine are called periodic functions. Okay. After 2 pi, it just repeats itself. Right, so f of t plus big T is the same as f of t for all t in the domain. So that's what it means to have a periodic function. So, both sine and cosine are periodic functions, period being 2 pi. Now what they're trying to show you here on page 211 is these are periodic functions. Here the period is 2. Okay, if you just take any unit of 2 and copy and paste, same. Okay. Here the period appears to be 4, I guess they're saying, from 2 to 6, right? So copy 2 to 6, paste, same thing. And for a trig function, this looks like a sine function. Look between 0 and 2 pi. That's one complete unit. Copy, paste, and so on. So you get the same thing there. So both sine and cosine have periods of 2 pi. Okay, we've talked about this before. Pi over 4 for sine and cosine, they were both radical 2 over 2. Okay, so the book goes with a derivation. I already went over a derivation, but sine of pi over 4, cosine pi over 4, both are radical 2 over 2. Okay. If you wish, you can put that in your cheat sheet. And then we went over this a little bit. Sine of pi over 6, cosine pi over 6. Sine of 30 degrees or pi over 6 is a half. 30 degrees is pi over 6. Cosine of pi over 6, radical 3 over 2. So here they drew a 30-degree angle. If you take a look, the y coordinate seems to be a half, right? If I put a point right here, it's about halfway through the, strictly speaking, it's exactly halfway. X coordinate seems way more than half, and it is. It's radical 3 over 2. Radical 3 over 2 is about 0.866. Let me try to show that to you on a calculator. Let's see, square root of 3 divided by 2, way more than half, 0.866. 86.6% of the way across the circle. Okay. But the y coordinate looks like it's a half. Now, if you look at 60 degrees or pi over 3, there's a reversal. It looks like the x coordinate is now a half, right? If it comes straight down, the x coordinate seems halfway across the circle. Y coordinate seems way more than half. And it is, it's radical 3 over 2. You just reverse them. Cosine of 60 degrees is a half. Sine of 60 degrees, radical 3 over 2. So here are some key points. Again, if you want to put that in your formula sheet, you may. So here's 1, 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Radical 3 over 2, comma 1/2. Radical 2 over 2 for both x and y. Notice this x and y are completely reversed. 1/2, comma radical 3 over 2, and then 0, comma 1. All right. Again, theoretically, this is not new. It should be review. Okay, so I realize if this is the first time you've ever heard it, so if this were a trig class, if I were teaching a trig class, then I would go slower, but I'm going faster because in theory, you've seen all this before. All right, and we've seen this before. Little mini table. And if you want to put this on your formula sheet, you may. Okay, for key angles, 0, 30 degrees, pi over 6, 45 degrees, pi over 4, 60 degrees, 90 degrees. If you wish, I can put the angles here. 30 degrees, 45 degrees, 60 degrees, 90 degrees. Notice the cosine and sine just reverse. So cosine goes 1, radical 3 over 2, radical 2 over 2, 1/2, 0. Sine completely reverses. So you notice 0, 0, 1/2, radical 2 over 2, radical 3 over 2, and 1. Okay. Okay, next big concept on page 214, reference number, or sometimes reference angle. I actually prefer reference angle. You may have heard of reference angle. For any real number t, the reference angle r associated with t is the shortest distance along the unit circle from t to the x-axis. For any t, the reference number is between 0 and pi over 2. Okay, you have an example in each quadrant, and you're welcome to put this on your formula sheet if you wish. Okay, so what's going on here? So here's a first quadrant, second quadrant, third quadrant, fourth quadrant instance. Maybe I'll write it down for you if it helps you. Quadrant 1, 2, 3, and 4. It's supposed to be a 4, IV. Maybe I'll just do it again. Okay, what are they saying here? If you're already in the first quadrant, the reference angle is the same as the angle itself. That makes sense. It's already a good case. So if the angle is 60 degrees, the reference angle is 60 degrees. The reference angle is always between 0 and pi over 2, or 0 and 90. What if I have a second quadrant angle? So what you do is you take this angle and come down to the x-axis. So if this is t, this is pi minus t, or in degrees, 180 minus t. So this is the reference angle, pi minus t. Third quadrant, you're over here. Again, the rule is you go back to the x-axis. So this is the reference angle, t minus pi, or whatever this angle is, minus 180 degrees. This is the angle that you want if you have a third quadrant angle. And finally, if you have a fourth quadrant angle, whoops, this angle here is your reference angle. Well, if I go all the way around the circle, that's 360, but I back up t, right? So it's 360 minus t, or 2 pi minus t. Okay, so here's what you do in each quadrant. Quadrant 1, reference angle is the same as the angle itself. Second quadrant, reference angle is pi minus t. Third quadrant, t minus pi. Fourth quadrant, 2 pi minus t. Of course, it's a little bit harder in radians compared to degrees, but you just pick the right one for each case. Okay, and we'll practice some of these presently. Okay, so let me show you the homework for those of you who don't have the book and aren't planning on getting it. We are up to here, so we're here, 1 to 55 odd. Okay. So it's everything on this page. So page 219. Whoops. Try to get this thing on focus here. Here we are. Some more. Okay. Some equations here. All right. So find a reference number. So the most useful situation is if they give us one of each quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. So let's go ahead and see what they give me. Okay, this 0 with a slash over it, that's theta. That's the reference angle. Okay, 1a, pi over 4. That's first quadrant, 45 degrees. Reference angle is the same. It's theta, pi over 4. So the best case scenario is if you're in the first quadrant, the reference angle is the same as the angle itself. It's already a nice angle. 1b, pi over 3. That's roughly 60 degrees. Same thing. Reference angle is pi over 3. Theta is pi over 3. However, C, T is 2 pi over 3. That's 120 degrees. 60 degrees. So how do you know? You can either memorize it or you can do the conversion formula, right? Convert degrees to radians, radians to degrees. 120 is second quadrant. So this angle is the reference angle. That would be 60 degrees, or in radians, pi over 3. How about D? 3 pi over 4, that's also second quadrant. That's way over here. So this is the reference angle, 45 degrees. 45 degrees is pi over 4. So theta is pi over 4. Okay, then a little bit of a timeout. Show you these circles in radians, just to get you comfortable with radians. It's almost like a brand new clock. So here's one way you can do this. I mark off every 45 degrees. Pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, pi, 5 pi over 4, 6 pi over 4, 3 pi over 2, 7 pi over 4, 8 pi over 4, which is 2 pi. Okay, so you might find this useful. And then here I'm going every 30 degrees, which is pi over 6. Okay, so every pi over 6. So here's how I count on this clock. 1 pi over 6, 2 pi over 6, pi over 3, 3 pi over 6, and I'm getting a message your meeting will end in 10 minutes. Okay, so just as I thought it would. 3 pi over 6, 4 pi over 6, 2 pi over 3, 5 pi over 6, 6 pi over 6, pi, 7 pi over 6, 8 pi over 6, 4 pi over 3, 9 pi over 6, 3 pi over 2, 10 pi over 6, 5 pi over 3, 11 pi over 6, and 12 pi over 6, which is the same thing as 2 pi. So everything reduces fine and dandy. Okay, 5. So once again, to give you all these angles, and they're trying to ask you what the reference angle is. So 45 degrees, reference angle is 45 degrees. B, 150 degrees, second quadrant, that's over here. So the reference angle, it's the angle that is made with the x-axis, and it's always between 0 and 90 degrees. So that's this angle. So how much is that? Well, this is 180. If I take away 30, I'm at 150. So I want 150. See, 240 is all the way here. That's in the third quadrant. So I want to go back here. So how much is that? 60 degrees, right? Because it's 180. And finally, D, 330. Okay. If I go all the way around the circle, that's 360. Back up 30 degrees, 330. In fact, I just gave away the answer. It said back up 30 degrees. So the reference angle was 30 degrees. Okay, so no big deal there. Okay, a couple more things I want to show you, then I think I'll quit because time is about to run out on me. This is useful. Okay. At every angle where the reference angle is 45 degrees, reference angle is 45 degrees here, 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 and here, right? That's 45 degrees, 90, 135, 180, 225, 270, 315, 360. Okay. I'm not writing it down because you don't need to. You can always derive it. I do want you to think of radians. Okay, this is pi over 4. So again, if you count pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and then reduce as necessary, right? Notice right here, 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 and here, both x and y are radical 2 over 2. No change. And then I just figure out the correct sign, SiGN. First quadrant, x and y are both positive. Second quadrant, x is negative, y is positive. I mean, you already knew that from algebra 1, right? Third quadrant, x and y are both negative. Fourth quadrant, x is positive, y is negative. So there we go. So all I do when I get here, 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 and here, I immediately put down radical 2 over 2 for both of them, and then just get the correct sign, SiGN. Say, okay, is it positive or negative? And that leads me to this. Here, I want you to show you what happens if the reference angle is either 30 or 60 degrees. Okay. If the reference angle is either 30 or 60 degrees, one of the coordinates is always going to be plus or minus a half, no exception. And 1/2 is always paired with radical 3 over 2, no exception. I just ask myself, is x or y 1/2? Okay. So here's a 30-degree angle. Doesn't have to be that exact. So I look for the x or the y coordinate. Okay. Does it look like the x or the y coordinate is 1/2? Well, this looks way more than a half. That looks like it's a half. So I put y coordinate as a half, which automatically means the x coordinate radical 3 over 2. Now let me look at a 60-degree angle. Again, I ask, does it look like x or y is halfway? Again, it doesn't have to be that exact. That y coordinate looks way more than halfway. But this x coordinate, well, the way I drew it wasn't that accurate, but that certainly looks closer to halfway than that. So I make the x coordinate 1/2, which makes the y coordinate automatically radical 3 over 2. Okay. So that sort of tells me what to do from that standpoint. All right. So I think that's about all I was going to do today. And I'm going to run out of time in about 4 minutes anyway. I don't know why the Zoom is doing that for me now. I guess we're limited to 40-minute lectures. So again, from now on, until I can finally resolve this, maybe I never resolve it, but I'll try to log on right at around 9, 10-ish rather than joining early, because if I join early, that means I have less time to start. So again, it doesn't start when I press record. It starts once I log into Zoom. And I kind of mess up at the beginning too, so I wasted a minute there. All right, so I'll try to join right at 10 after from here on out until I can figure out the 40-minute limit for Zoom. If it never happens, then we'll stop after 40 minutes. I'm sure many of you don't mind anyway, but that's the way it goes. Okay, so I think I'll just stop there and continue tomorrow. Anybody with a question? Let me check the chat and see if there's any questions. Otherwise, we'll quit. And we have to quit in about 3 minutes anyway. So let's see. I don't see anything in the chat offhand. Okay, any other questions, please? All right, then have a good day, everybody, and we'll see you next time. Okay, all right, bye, everybody.
Could you just put up the paper paper one more time? I just wanted to see the circles again.
I'm sorry?
Could you put up the paper one more time? I just wanted to see your drawings of the circles one more time.
Okay, let me see quickly. Um, Give me this one.
The one where you, yes, that one. And then the
Okay.
ones below D on
Okay,
question
this
one.
one. All right, this one here.
Yes,
Okay, we're going to be timed out in about 2 minutes.
that's
If
great.
you don't
That's
get it, you
enough.
can
Thank
look at the
you.
video also.
Yeah, that's perfect. Thank you.
Melvin, in
Yes.
the text, you put letters. So you put like A in the first quadrant. I think like T was in the second quadrant. What do those letters represent?
I'm not sure what you mean by the letters.
In the
T?
text. No, it's
The
in the
T?
textbook. And when it not here, like there was
I don't know what you're talking about. Sorry. Unless you tell me which page or whatever.
I'll go on to your office hours and I'll ask.
Okay.
I'll figure it out.
All right. Okay. Anybody else, please? Yeah, I see your remark about this is supposed to be from college, so.
Yeah, so
you're
I was
supposed
just
to pay
telling you
it.
that it's probably on their end. You probably have to contact the school or something.
Yeah, I did, and they're not helping me.
Okay.
So,
So I'd throw that out there. I'll see you soon.
yeah, okay. Anybody else with a question? All right, we've got to bump out in a minute anyway. Okay, bye, everybody. We'll see you soon.